Welcome. Hello, everyone. Thank you for joining us at our Watershed Wednesday program, sponsored by E&E Systems of Canton, Massachusetts. I'm Jennifer Rogers, River Restoration Director for NepRWA, and I will be your moderator today. The Neponset River Watershed Association is a small nonprofit, member-supported group with a mission to protect the Neponset River, its tributaries, and surrounding watershed lands. Today's presentation will be by Declan Devine, this year's fantastic Environmental Fellow, and he will be speaking about water quality monitoring in the Neponset, specifically our swim-in program. The presentation today will last for about 45 minutes, and then there will be 15 minutes for questions and discussion. So with that, I will give it to Declan. Take it away.
All right, hello everyone. Thanks for joining us. We're really excited you're all here. Again, I'm Declan Devine. I'm the Environmental Science and Engineering Fellow for NepRWA. And today we're going to be talking about water quality in the Neponset watershed. My background is in, my degree is in civil engineering and geology, and I've worked with Trout Unlimited and the Forest Service on restoration projects, and I've also worked with a few other municipalities on their water quality monitoring program. Our agenda for today, we're going to start off with some information about the Neponset and about NepRWA. And we're going to talk about our water sampling program, go through some of the results for this year, as well as the historical trends. And then we'll finish up with what kind of actions we can take both at the individual and community level to improve water quality. All right, so this is a map of the Neponset watershed. It flows from kind of the bottom left of the map, and Foxborough is where the start of it is, and flows towards the upper right end of the map with streams throughout entering the main stem, and then it eventually exits into Boston Harbor up by Quincy and Dorchester. So there's 33,000 or 330,000 people live in the watershed. So they're all interacting with the watershed every day, whether they know it or not. And about 120,000 people will actually get their drinking water from within the watershed. NepRWA was started in 1967 to clean up and protect the Neponset and its tributaries. We are a grassroots conservation nonprofit, as Jenny said, and since 1967, our mission has expanded a lot. So now we do a lot of advocacy as well as improving green space and focusing on the whole watershed, not just the streams. So the Neponset has a history with a lot of pollution because it was one of the first kind of rivers that saw a lot of human impact in the US. And so there used to be a lot of industrial pollution and sewage pollution coming into the river. And in order for NepRWA to clean it up, we wanted to know what the problem really was. So in 1995, they started the Citizen Water Monitoring Network, also known as swim-in, and have been collecting water quality data ever since. There's a couple of reasons on why it's important to monitor water quality. One is so that we can track changes over time. We can see which pollutants are improving, which are getting worse. And we can also look for impacts from our efforts. So if we're working a lot in a particular area, we can see if we notice a response in the water quality in the water bodies in that area. Second reason it's good to monitor water quality is so that we can identify where we need to focus our resources. So we can look and see where are the worst areas where we can maximize the benefit from our efforts. In terms of the logistics, there's 41 sample sites throughout the Neponset. Each site gets tested 6 times throughout the spring, summer, and fall. It's all done by volunteers, so big thank you to our volunteers. I know a lot of them are here today. And then all the samples are analyzed either by NepRWA volunteers or the NepRWA lab. This is one of our longtime volunteers, Jim, testing pH samples. So we're going to be looking at the data from 2020 today, mostly, and these are some questions to guide us in looking at the data. First question is, how healthy is the water? So how close are we to meeting our goal of a clean Neponset? Is it safe for recreation? Is good for the ecology living there? Our second question is, how has water quality changed over time? So today we'll be looking at data going back to 2006. We want to see what things are improving, what's getting worse. And then the last question we're going to be looking at is, how does water quality vary throughout the watershed? So as we saw, it's a large area with a diverse land use. So we're going to look at how things vary from place to place. We test the samples for 9 parameters listed here. We're going to focus today on those first 3 because they're some of the most important ones and where we have the most complete data. So I'll just go through them briefly now, but we'll go into more detail later. E. coli is a bacteria that affects human health. Phosphorus is a nutrient, like a fertilizer, that helps with plant growth, and dissolved oxygen is needed for anything living in the water. And this is one of the people in our Excel program testing some pH samples in the picture. So E. coli, like I mentioned, it's a bacteria. It comes from human and animal waste. And so we monitor E. coli because it's an indicator often of the presence of other pathogens found in waste that can make people sick with diarrheal diseases, amongst other things. Where is E. coli coming from? How does it get into the river? There's 2 main sources. One is through problems with the sewer system. So if the sewer system is leaking or improperly installed or anything like that, or if there's a big flood, E. coli can leave the sewer system and enter the river. And the second main source is through stormwater runoff. So stormwater is the water that runs off of your roof or your road or sidewalk when it rains, and it goes into one of these grates that we can see at the top 2 pictures, and then it goes straight into a pipe that empties into the river without any treatment or filtration or anything like that. So a lot of people ask, like, oh, is the Neponset safe? We try to answer that question in a way. And so the Massachusetts DEP has standards for how much E. coli they say is safe for swimming and boating. So at low levels of E. coli, it doesn't have any effect on your health. It's safe. So this pie chart is showing for the year 2020, all of the samples we collected, what percentage of those samples were safe for swimming, shown in blue, safe for boating in yellow, and then unsafe, shown in red. So you can see most of the time, most of the places in the Neponset, the water is safe for recreation. But it's a lot more complicated than that chart because water quality depends a lot on precipitation. So when it rains, the rainwater washes lots of pollutants into the river. So here we have similar pie charts. The one on the left is showing the data, the historic data for after there's been precipitation, so after it's been raining. And then the chart on the right is showing after it hasn't been raining, so after dry weather. And then it's the same blue for swimming, yellow for boating, red for unsafe for recreation. And you can spot a few differences. With wet weather, we have like 3 times as much unsafe for recreation. And also with wet weather, the number of swimmable samples drops from 69% to 46%. So precipitation has a big impact on the water quality. So you should generally avoid swimming right after it rains. And moving forward in the presentation, the rest of the data will be weighted according to precipitation. So because we have about 2/3 of the days of the year have dry weather, we consider that dry weather pie chart to be more representative of what the data is, or what the water quality is on a day-to-day basis. So we'll be giving that dry weather data a bit more weight. So it'll be weighted twice as much as the wet weather data to represent how often we have dry conditions. So the second question we wanted to answer was, how does water quality change over time? So this graph is showing from 2008 to 2020, the percentage of samples that were safe for swimming. And it's a 3-year average just to smooth things out. We can see there is somewhat of a downward trend. If we look prior to 2014, we usually had around 60 to 70%. But then after 2014, we usually have below 60%. There's a few factors that may be contributing to this trend. One could be there's been some modest population growth in the watershed, so a bit more development. Other things are like aging infrastructure. So there's still lots of old cast iron and terracotta sewage infrastructure in the Neponset watershed. And so as that infrastructure ages, it's more likely to leak. We've also had more extreme weather events. With climate change and that type of flooding can actually, if the rainwater gets into the sewer system, it can cause the sewer system to overflow and get into the river. So that's what's going on in this picture in the bottom right. That's during a flood, the sewer system can overflow. So they put this big block on top of the manhole to prevent that, but you can see some is still squirting out the sides. And then this picture in the upper right-hand corner is someone from the Milton DPW repairing an illicit connection. So a problem with the sewer system that was allowing sewage to get into the river. So it gets a bit confusing to look at all these numbers all the time and all the years, and there's swimming standard and boating standard, and it can be overwhelming. So something we're trying to do is to simplify the data a little bit. So what we're calling our report card, the Neponset River report card. And it's something we've been working on with the EPA and some of the other watershed associations that in the area that already produce a report card. And basically the idea is to assign each water body a letter grade that represents how often the bacteria levels are acceptable. So we're still working on some of the kinks, but I'm going to give you all a sneak peek, and it's also going to help us answer our third question about how pollution varies geographically. So just to orient you to the figure, on the left, we have a list of all the water bodies in the Neponset, as well as this percentage, which is listed as their average compliance rate, which is kind of like a fancy calculated way of saying how often is that water body have an acceptable level of E. coli, or a safe level of E. coli. And then each stream has been assigned a grade correspondingly. And then each stream on the map you can see is colored based off of its grade. And the map is similar to what we were looking at before, where the Neponset's flowing from the bottom left up to the upper right-hand corner of the map. Some things to notice: some of the problem areas are like Unquity Brook over by Quincy, and then Germany Brook, Meadowbrook, and Purgatory Brook in Norwood. In general, a lot of the ponds have pretty excellent water quality when it comes to bacteria, as well as a lot of the streams in the East Branch system, kind of in Sharon and Stoughton. And in terms of what is influencing these variations, there's a lot of factors at play, but a big one is just the amount of development. So the more development means more paved surfaces contributing to stormwater runoff and more sewer infrastructure both of which we talked about can contribute to E. coli pollution. So, for example, Sharon has less development than Norwood, and we see in Norwood a lot of more common E. coli issues. Other factors that can play in are like the age of the sewer infrastructure or the particular design of the sewer infrastructure that was used. All right, so finished up with E. coli, we're going to move on to phosphorus. So phosphorus is like a fertilizer. So it's a nutrient that plants and algae need to grow. And how's it getting to the Neponset River? Again, it's mostly through stormwater. So there's lots of phosphorus in organic material, so grass cuttings or leaves, as well as in some fertilizers. So when it rains, those pollutants can be washed into the stormwater system and into the river. Other sources can be from car exhaust, has phosphorus in it, so the rain can bring the phosphorus out of the air and into the stormwater system, as well as improperly maintained septic systems can leach phosphorus as well. And why do we care about phosphorus? So like I said, it's like a fertilizer, so it can lead to algae blooms. So once all the phosphorus gets into the river, the algae are like super excited that there's all this phosphorus and they can grow a bunch. And when you have too much algae, it has some negative impacts on the river. And then once all the algae die and decompose, it uses up all the oxygen in the water, which is harmful for anything else living in the water. So there you see a picture of a algae bloom in Canton Reservoir. So that's what we're trying to avoid. So then these pie charts again are showing the results from this year's sample. You can see 2020, and then from historical sampling on the right. The red area is showing the percentage of samples that had unhealthy levels of phosphorus. So this year it was 65, which is quite high. And then historically it was about 46%, which is still quite poor, but is not as bad as this year. And we'll go into a little bit more detail about why that might be. And how we define healthy and unhealthy is based off of a standard set by the EPA. And there's one for rivers and one for lakes. So look at the phosphorus levels over the last 15 years. Again, we see the percent on the y-axis is the percent that were healthy, and then the x-axis is the years. We don't really see a super strong trend. It's generally between 50 and 60%. Looks like maybe there's been a trend in the last 4 or 5 years, but we'll have to kind of keep an eye on it and see what happens. And NepRWA has kind of ongoing efforts to, with all of these pollutants, to better understand where they're coming from and to address their sources. This is a photo of some algae growing in Ponkapog Brook. So now we're going to look at a similar map to what we just looked at when we were discussing E. coli, but this one is showing the phosphorus results. So you probably see a lot of red, which means that most of the watershed has a phosphorus problem. You know, in some places like Massapog Brook and Steep Hill Brook in Stoughton and Sharon, the phosphorus levels are actually pretty healthy. This is maybe in part due to having more wetlands and more forested area in that section of the watershed, so which means less stormwater bringing phosphorus in. In terms of what's causing the high phosphorus in other places, it varies as well. So for example, Crack Rock Pond in Foxborough has really high phosphorus that's connected to legacy pollution, so historical pollution that is all in the mud at the bottom of the pond and is just leaching out over time. And then Ponkapog Brook is also one of the worst sites for phosphorus in Canton. And it flows right through a golf course and under several large roads, so those can be some of the factors that are affecting the phosphorus levels as well. So now we're going to move on to our third parameter, which is dissolved oxygen. So just like you can dissolve salt or sugar in water, you can also dissolve oxygen in water, and that oxygen in the water is like the air that fish and aquatic insects need to breathe. So this is a picture of a brook trout, which are native to the Neponset, and need a good amount of dissolved oxygen in order to survive. What affects dissolved oxygen? There's a few factors that can influence it. A big one is flow. So in stagnant or still water, there's less dissolved oxygen than in water that's flowing well and mixing and going over rocks and logs and stuff like that. And that's why people have those bubblers in their fish tank and that type of thing. Water temperature has a big effect as well. So cold water can hold a lot more dissolved oxygen than warm water, which is part of why trout love cold water. And the last factor, which is something we touched on already, is decomposition. So like we said, when the algae or any other organic material in the river, like leaves or grass, when that material decomposes and little microbes are eating it up, they use up a bunch of dissolved oxygen. So the more decomposition you have going on, the more dissolved oxygen will be used up. So for dissolved oxygen, we consider anything, any site having more than 5 milligrams per liter healthy, and anything below that unhealthy. This pie chart on the left is showing the results from 2020. So about 77% of the samples we collected had healthy levels, which is pretty good. When we compare this to the historical data, this year was a little bit lower than in the past, when we had on average 83% of samples had healthy levels of dissolved oxygen. It's a pretty small difference, but it's worth noting because typically we don't see much variation from year to year. And this is a mayfly. So before the mayfly is able to fly around, it lives most of its life in the river, and it needs dissolved oxygen in order to do so. Those are its gills, those little feathers sticking off its side, or its gills. So if we look at the dissolved oxygen trends over time, we can see that it is usually pretty high, between 80 and 90%, but there's definitely a gradual downward trend. This is most probably a result of climate change. So as we've seen warmer temperatures, we said warmer water can hold less dissolved oxygen, so that's probably bringing it down. And we've also seen more frequent and more intense droughts. So when there's less water in the river, it's more likely to be stagnant, which harms the DO levels, and then it's also more likely to heat up. So yeah, this is definitely a concerning trend. And you might look at it and say, okay, well, 80% of the water is places that have a healthy level, and 80% are where fish can live, which is okay, pretty good. But it's important to consider how the dissolved oxygen changes throughout the year. So all of the parameters we're looking at vary throughout the year, but dissolved oxygen has an especially large variation. So here I've plotted the percent of samples with healthy levels during every month of this year's sampling season. So we see in May, we start up pretty high in the upper 90%. That's great. With June, it goes down a little bit. And then in August, the dissolved oxygen levels drop down to near 50%. So during the summer, as temperatures warm up and the streams get drier, the dissolved oxygen levels fall a lot. But fish need to be able to breathe in every month of the year. So it's really concerning when we see the drops during August. and it kind of brings into consideration a couple other points I want to talk about. One is aquatic connectivity. So if during August only half of the water in the watershed is healthy trout habitat, the trout need to be able to move throughout the watershed. So they need to be able to move from places that were fine habitat during May, but are poor habitat during August. So they need to be able to move throughout the watershed, and there's lots of barriers preventing them from doing so. So there's over 100 dams in the Neponset that limit the ability of fish and other aquatic organisms to move throughout the watershed. So one of the efforts NepRWA is working on is to remove some of those dams when appropriate, to expand the amount of habitat that fish have access to. Another point that's really well illustrated by this graph is the importance of water conservation. So all of the streams in the Neponset during most of the year are being fed by groundwater. So there's water from underground that's seeping into the streams and providing them with most of their flow. And like we said, there's 120,000 people that get their drinking water from the Neponset, and that's also coming from groundwater. So essentially the people in the stream are both competing for the same resource. And so the more water we use, the less water will be available for the stream. And so we're more likely to have these dry, hot areas with low dissolved oxygen. So that's kind of why it's really important to conserve water, especially during the summer months. So this is a map of the dissolved oxygen results. Again, we have each water body in this table on the left with their associated grade, depicting how often the dissolved oxygen levels were healthy. We see a lot of green, which is awesome. Most of the year, most of the Neponset has healthy levels of dissolved oxygen. Some of the problem areas we see are like this upper section of the Neponset in Foxborough, Peckwick Brook in Canton, as well as Mine Brook. And what's causing the problem areas? Again, it's a few factors. Part of it is linked to phosphorus. So we see places like Ponkapog Brook, where we said we saw high phosphorus, and Crack Rock Pond, where we also saw high phosphorus. Those phosphorus levels can lead to algal growth and resulting low DO. We also said that stagnant water can cause low dissolved oxygen, and we see that effect in a lot of the ponds. So like Turner Pond, Ganawati Farm Pond, and Crack Rock Pond. Because the water is stagnant, it's just sitting out in the sun and heating up, and so it doesn't make for a healthy level of dissolved oxygen. All right, so just to overview what we've covered so far, I know there's a lot of data, so I tried to synthesize it down. E. coli is a bacteria, affects human health. Usually it's at a safe level, but after it rains, the levels become less safe and it's trending down. So it's getting worse over time. Phosphorus is like a fertilizer that is used for plant growth. And it's pretty poor throughout the watershed, and especially linked to stormwater pollution without really a strong trend. Dissolved oxygen is needed for organisms living in the river, and usually it's pretty good, but it does have that seasonal variability we discussed, and a gradual downward trend likely linked to climate change. So now that we've talked through all of the data, we're going to briefly touch on what can be done both at the community and individual level to address some of the problems we see in the watershed with water quality. So a big community solution is improving stormwater infrastructure. So most of the pollutants that get into the river arrive there via the stormwater system. So NepRWA is working with most of the towns in the watershed to install what are called best management practices, or BMPs. And these are typically depressed areas or low areas nearby a storm drain where water can pond up and soak into the ground as opposed to going into the drain, which will pipe directly to the river. And that soaking is really good because as the water slowly soaks into the ground, it'll filter out a lot of the pollutants, and it'll also slowly feed into the groundwater system, which will gradually feed the river. So instead of all the water going super fast through a pipe to the river, it goes slowly through the ground, which helps avoid some of the really low flows that we have been seeing. Some towns are implementing what's called a stormwater utility. So just like we have utilities to pay for our water and sewer, it would be a utility to pay for the stormwater that we are all creating. And those are really important for being able to fund these projects that help with water quality. A few other community solutions we can talk about. One is land conservation. So the less land that we have paved, the less stormwater pollution. So that's a pretty straightforward one. And all of these are things that NepRWA is working on. Another big one is water conservation. So like I said, and kind of what's being shown in this bottom diagram is that human water consumption through wells is drawing off of the same aquifers as the streams draw off of. So the less water that we use, the more water will be available for the streams to maintain healthy flows throughout the year. And there's lots of awesome information on our website about water conservation as well for you to check out. And then the last thing I have here is education. So teaching both kids and adults about water quality and about water use and water conservation and stormwater is really important for spreading awareness about some of these issues so that we can take action to fix them. So what can you do as an individual? One thing you can do is contact your legislators. So you have power as a citizen to affect policy in the state and in your town. So if you keep an eye on our website, there'll be updates for when there's relevant policy coming up. And there's one right now, actually. After this, you should go and call or email Governor Baker and tell him to sign the climate bill that is on his things that you are use water. So we talked about that a lot already, but less water you use, the more water available for the river. Picking up and properly disposing of pet waste is important. Unfortunately, our dogs can't do what is shown in this picture. So we need to dispose of the pet waste so it doesn't bring E. coli into the river. Servicing your septic system regularly is important for preventing phosphorus leaching into the river. Reducing or eliminating fertilizing is good as well, because a lot of the fertilizer, when it rains, can run off of your lawn and into the stormwater system. And then the last thing I have here is talking to your friends and family. So it could be about what you learned today or things you notice about the river, or when you see a storm drain, just kind of pointing it out. And the more awareness people have about these issues and about the river and the water pollution, hopefully we'll be able to take more action both individually and as a society. So I want to give a big thank you to all of our volunteers. This program is almost entirely run by volunteers, so we wouldn't really be able to continue it without them. If you're interested in volunteering, definitely send me an email, or if you know someone who's interested. It's pretty fun, and we'll have a few openings this year for sure. I also want to thank the Massachusetts Water Resource Authority because they do a lot of our lab work. So we're really grateful for them. And then lastly, I want to thank our donors and members who make a lot of the work that NepRWA does possible. They fund my position and a lot of the other efforts that NepRWA is working on. That's the end of my presentation. We have a few more Watershed Wednesday talks coming up, so you can sign up for them on our website. I also want to thank E&E Systems for sponsoring this series of Watershed Wednesday talks. We're really appreciative to them. And now we're going to move on to questions. And if we don't get to all the questions today, you can always email me. My email is there.
Okay. Super, Declan. You covered a lot of information and not a lot of time, so that was great. So we've been getting some questions via the chat during the talk, and we also got some questions via email. So I'll just start going through them one by one. And a reminder to everyone that this is being recorded. And now that Declan is off of Spotlight view, if you don't want to be recorded, make sure you turn off your camera. And you can turn off your camera at the bottom of the screen next to your mute button. So let's see. The first question we got was actually answered, but Declan, you might be able to expand on it a little bit. It was about if it's safe to swim, is it also safe to boat and kayak? So Declan, perhaps you could touch on the thresholds for E. coli for swimming and boating, and which activities have more strict thresholds?
Sure. So, I mean, we were looking at the E. coli data, and I can go back to that slide. Most of the time, it's safe for boating, definitely. There are a few areas that we see higher E. coli levels than the boating standard, but generally, most places, as long as it's not right after a rain, it's safe for boating. And then most of the ponds, again, safe for swimming, but generally you shouldn't really right after a big rainstorm. And those thresholds are determined by the Mass DEP sets them. And you know, the swim monitoring program isn't really designed to be like a rapid alert type assessment program that some other watersheds have, where they you know, immediately after rain they're testing to warn people. So it's more of like, so we can get a general idea over the long scale of time.
Super, great. And yeah, just to add to that, the answer is yes. If it's safe to swim, then it's definitely safe to boat, because they set a much stricter threshold for swimming because people are interacting with the water and could potentially drink the water or get it in their nose or something.
Oh, I see. Yeah. Mm-hmm.
So let's see. So next question was, does dissolved oxygen affect pH?
Probably. I'm not totally sure. Like, I'm sure it has some sort of effect, because probably affects this. Yeah, because it probably affects the amount of CO2 also in the water. Generally, like the pH throughout the Neponset is pretty healthy. So like we collect pH data every month as well, and it's almost always in a healthy level, which is why we don't really present any of it. But I don't know if Jenny, you have anything to add about that, but we don't really see any issues with the pH regularly.
Yeah, I'm not sure either. I don't think there's a strong relationship between the two variables. There might be something more indirect, like, you know, lower pH and corresponding increase in hydrogen ions could, you know, theoretically interact with the oxygen, or the way the dissolved oxygen supports plants. There could be something indirect, but I'm not sure. Maybe there's a aquatic chemist on the call to jump in. We can look into that question more and respond to the individual who asked that question specifically. Okay, next question. Why are there no dissolved oxygen reports for Willett Pond?
That is a good question, and it's related to like our historical like how we've historically collected data there, and I honestly don't know the answer on why we monitor dissolved oxygen in certain locations and not others. I assume it has to do with like when the initial watering or water quality monitoring sites were set up, they were kind of trying to focus on problem areas. So it may be linked to that, but I don't really have a great answer for that either. I can get back to you about it.
Yeah, maybe it was, let's see, Doug Bercheski asked that question. So maybe he can follow up with an email to us and whether or not he has a recommendation to start sampling there. I think we're always open to changing some of our sampling sites. Okay, let's see. So there were two questions that we got via email. Has the sampling always been done only in the water or also the soil and sediment in and around the river?
So this citizen water monitoring network has always been only on the water sample or only sampling water quality, but there have been some efforts by NepRWA and other organizations historically to test soil both in the river and on the banks, particularly for PCBs. So I know that there was PCB testing done for soils in the lower Neponset, as well as on Meadowbrook as part of the Superfund designation and a few other places, but we don't really have any like regular sampling programs addressed at sediment sampling.
Okay, next question from the chat. How do you prioritize the red segments for corrective action? So I'm assuming that's referring to the report cards and the ones that got a failing grade. How will we prioritize those in the future?
Was that with respect to a certain parameter or just kind of generally?
It doesn't say.
Okay.
Probably just general.
So one of the things that we do is hotspot monitoring. So when we find an area that has a problem, we go and do more intensive sampling in that area to try to zero in on where precisely the pollution is coming from. And then just kind of, it also helps drive all of our efforts to reduce other pollution sources. So it might mean we're focusing more of those best management practices that I touched on to reduce phosphorus pollution in the areas near those red water bodies. Or maybe we're doing more educational programming or water conservation efforts in areas that are red for dissolved oxygen.
Okay, let's see. Another question we got via email. Do sewer lines or wells along the river pose any risk to the river? The question is specific for Norwood, but I would say maybe answer that question just generally speaking.
So a lot of times the sewer line runs near the river because the sewer is gravity powered. So they tend to put the sewer lines in a low elevation area, and the river is also usually in a low elevation area. So a lot of times they're nearby each other. And so there is a risk definitely in that the sewer system, if it's leaking, it can leak E. coli or sewage into the river, or if it overflows during a flood. So if there's a flood and somehow water from the river or water from the stormwater system can get into the sewer system, that will often like overwhelm the capacity of the sewer system, and water will come out of the sewer system, bringing sewage with it. So it's definitely a risk, but there's things that can be done to minimize the risk of sewage lines nearby water bodies.
Great. Okay, and so there's one more of a comment. Oh, no, we just got another one. So let's see. This one looks like more of a comment, but I'll just read it so everyone can hear. I work with MassDOT as the stormwater program coordinator. I have a stormwater project to be set to bid and constructed by spring of 2022. I am proposing BMPs on Boston Providence Turnpike Route 1 in Walpole, as well as infiltration swales along I-95 between Canton and Norwood. These BMPs are aimed to treat mass DOTS roadways for pollutants that you talk about today. So, right, not really a question, but definitely related to some of the things that Declan covered today. So we can follow up with this individual to see how our programs are related and how we can work together, for sure.
Yeah, and Hung Pham is also one of our regular samplers, so I want to give him a shout out for doing an awesome job, both with his job with MassDOT, getting BMPs done, and also with his volunteering with NepRWA.
Sure. Let's see, another question came in. I wonder if it might be useful to work with local conservation commissions connected to the Neponset River to provide this education and updates, which would broaden audience reach and raise awareness.
Yeah, that's a really good idea. We definitely work with most of the towns through the National Stormwater or the Neponset Stormwater Partnership Program to get like the NepRWA's educational curriculum to most of the towns in the Neponset. And I know we work with some of the conservation commissions. I'm not sure exactly like if we're working with them in the educational capacity, but it's definitely something we should look into.
Super. And I know Nancy and Andres are on this call also, and they lead a lot of the education initiatives for NepRWA. So definitely feel free to reach out to them if you have thoughts on how we could better broaden our audience reach and raise awareness. And then finally, will this recording be available later? Yes, so this has all been recorded and it will be posted on our website, neponset.org. So I don't see any other questions on the chat or that came in through email. Give it another minute, but mostly just some thank yous and great job, Declan. So let's see. Thank you everyone for coming. And thanks again to E&E Systems of Canton, Massachusetts for sponsoring this Watershed Wednesday. Someone just asked about this, but a reminder, this recording will be available, so feel free to share the recording. If anyone wants to be a volunteer for the 2021 swim-in season, definitely contact Declan. Like he said, the program is entirely volunteer driven. Also, if anyone sees any runoff or suspicious dumping by a stream, you can always contact our stormwater hotline, which is our main phone number with extension 300. And then finally, keep an eye out for our next Watershed Wednesday presentation on February 10th at 12:30. And this will feature officials from the mayor's office who will speak about the Climate Dorchester Ready report. And with that, I thank everyone for coming and see you next time.